Hi, so we're in chapter 7 and we're working on the exercise that we started in the previous video. We have the IQ scores with the mean, the standard deviation of 100 and then 16 and a sample of size 4. We determined that the mean was 100. The mu sub x bar, the mean of the distribution of the sample mean, is 100, and sigma sub x bar, the standard deviation of the distribution of the sample mean, is 8. Additionally, once we state that the IQs have a normal distribution, once I add that piece of information, which we didn't know, but I'm just going to add it explicitly. So once I add that the parent has a normal distribution, we can also then say that the distribution, the shape of the distribution of X bar is normal. Because that was the first row in the table. The parent population was normal, then all of the, for all sample sizes, the distribution of X bar is also normally distributed. Okay, so we can draw a picture of it. X bar, mu sub X bar is equal to 100. And sigma sub X bar is equal to, I'm just going to put that there just to remind myself that we already did it, sigma over the square root of n, and that is 8. And we are asked to find the probability that X bar is less than 105. Okay, so here's my 105. There's the picture of my problem. Okay, so how am I going to work this problem? Well, I have a normal distribution and I'm looking for a left tail. So because I know this is normal, I can work the two-bell problem, right? I can transform the X bar over to the Z world and do and then do one direct lookup. So what we want to do is go ahead and put 105 on a bus. Now, it's true, we have a nice formula from chapter in chapter 6 about how to put a normal variable on a bus and get a standard normal out. Z equals X minus mu over sigma. Now, the formula, of course, continues to be a valid formula, but when you're talking about sample mean, I just want to make sure that when you normalize, when you divide by the standard deviation, that you're doing it by the correct standard deviation. So for chapter 7, we have, and if you will, just go and look for a moment on your formula card. Another formula for Z, X bar minus mu divided by sigma over the square root of n. Okay, and all that really is just saying, let's use the standard deviation of the sample mean when we do our transformation, okay? So you really can use either one as long as when you divide, you're dividing by 8. You remember to use the standard deviation, that there is a context, right? So we're really interested in the context of the sample mean, the distribution of the sample mean. So we have Z equals X bar minus mu divided by sigma over root n. We know that's 8. And so the x bar is 105 and the mu is 100. So hope you can see that. All right, and we get then 5 over 8, and it's a z-score, so we're going to take it to 2 decimal places. 0.63. So now here. And what we're going to want to do is find the area to the left of 0.63. And that's going to be the same as the desired probability on the curve in the X bar world. Okay, so it's a left tail. And we're given the z-score and looking for an area. So it's going to be 1 direct lookup. Please follow. So check my work. I'm getting 0.7357. And that's the answer to the problem. Okay, great. So I'm going to move on in the notes and do the next problem. And that is, consider a random variable x that has, so let me just erase this, a mean of 50 and a standard deviation of 8. So x has a mean mu is equal to 50 and a standard deviation sigma equal to 8. A sample of size 64 is taken. And what we want to do before we answer any probability questions is determine the distribution of the sample mean. You know, we always say when we're describing distributions, we need center, spread, and shape. So that's just what we need here. We're looking for center, mu sub x bar, spread, sigma sub x bar, and shape, is it normal, is it not normal, okay? So in this problem, because we know that there's no statement about the shape of the distribution of the parent population. And so unless we know that we have normality, we have to assume we don't have normality. So we're in a situation where the shape of the distribution of x is either, you can think of it as unknown or not normal. So going back to the table, you have to determine what row we're on. We have, so I'm going to write this here, distribution shape, so is not normal. Okay, distribution shape is not normal. So that means that we are going to be on the 3rd row of the table, okay, because the shape is not normal, but the sample size is greater than 30. So we're in the 3rd row, and the parent, I mean the shape of the distribution of x bar is approximately normal. The mu sub x bar is equal to mu, which is equal to 50. And sigma sub x bar is sigma over the square root of n, which is 8, divided by the square root of 64, 8 over 8, or 1, okay? So we have here that the distribution of the sample mean is approximately normal with this mean and this standard deviation. Okay, I'm going to draw a graph And to calculate, so that's the first part of the problem, right? And then the second part of the problem, find the probability that X bar is greater than 52. Okay. Where along my journeys, I misplaced the notes, but at least I have them electronic here. So, okay, so we're looking for the probability that X bar is greater than 52. And since I have that the shape is approximately normal, I'm going to go ahead and jump in and draw my nice normal bell curve. And this is an X bar. Oops. Leave some room for the second bell, right? So we're going to use a two-bell method. We figured that out in the previous problem. So let's go ahead and draw two bells. This one here is X bar. It has a mean equal to 50 and a sigma sub X bar equal to sigma over the square root of n. And that's going to be equal to 1. This bell here is a standard normal. So let's draw the picture of the problem. Find the probability that X bar is greater than 52. Greater than. So that's the picture of the problem. And now what I want to do is I'm going to want to take the 52 and put him on the Z-bus and figure out where he falls over here. Okay. So put a little box down here. 52 goes on the bus. Z equals X bar minus mu divided by sigma over the square root of n. And that's 52 minus 50 divided by sigma over the square root of n, which is 1. And to 2 decimal places, we get this as 2.00. We are looking for the area to the right of Z equals 2.00. So right tail, strategy is 1 minus the direct lookup. So it's 1 minus 0.9772. Point 0228. Okay, so we see here, just to kind of review the problems, a lot of moving parts, I guess. We are given the distribution of the parent population. We do not know that it's normal, so we'll assume it's not normal, with a mean, standard deviation, and a sample size. And we use the results of chapter 7 in the table in the notes. We use that table to help us remember how to pull it out, but the distribution, because the parent is approximately normal with a large sample size, this was the third row in the table. We end up with this as the center spread and shape of the distribution of X bar. So once we knew that the distribution of X bar was approximately normal, we really move into a chapter 6 problem solution method. That is, draw a picture of the problem. You put your X bar on the bus, take it off, and do 1 minus a direct lookup. Okay, so I want now to move on to the next problem. All right, so the next problem has the same parent population, but with a different sample size. Consider a random variable that has a mean of 50 and a standard deviation of 8. if a sample of size 10 is taken, what is the mean of the standard deviation of X bar? What is the shape of the distribution of X bar? Okay, so it's the same problem, the same parent, but with a sample size of 10. So I'm going to go ahead and go back to the whiteboard and let's move it on. So the new problem has a sample size of 10. Okay. And so now we have to go back to the table, that chapter 3 table, chapter 7 results table. And we see that we have a parent population that is not normal and a sample size which is small, less than 30. So we're on the second row in the table. And now, then, the shape of the distribution of X bar is unknown. Right? We do know the mean and we do know the standard deviation, right? So the standard deviation is going to change because it's going to be 8 over the square root of 10. I'm getting 2.53. All right. So now we're all set there. In terms of determining the distribution of the sample mean. But the next problem asks for us to find the probability that X bar is greater than 52. And, you know, the second part of the problem here. So the issue with that is that since I don't know the shape of the distribution of X bar, I really can't do a normal calculation. So we really can't find this probability. And it's important to know that sometimes you just don't really have enough information about, in this case, the distribution of the sample mean to move forward in a problem. So, okay, that's it for this video. I'll see you in class or in the next video.